Welcome, this is your teacher David Garcia, and today we're going to be working with the topic of the slope. Now, before we set ourselves to solve some problems, okay, some examples, let's take a look at the main idea. And here, what we have here is an equation that describes all possible lines, all possible straight lines on a Cartesian plane. And the main components are very easy to identify. If you see, we have the variable x, which is the independent variable. We have the variable y, which is the dependent variable. And then we have two numbers, in this case, two letters. Okay, we have m and we have b. Now, I'm going to start with b because in this case is the least important and it's very easy to understand. B in this equation is literally the value at which the line, in this case represented by this equation, will cross the y-axis. So if you see, there it is. We have a little point in here that says 0, 1. 1 is the coordinate for the y on this point here. And if you see, the value for b is also 1. So if I start playing with this value, if I increase its value, you will see that the graph, the line, is moving upwards. Okay, if I set it up at 4, you will see that the coordinates for these points are now 0, 4. If I decrease the value, you will see that it is going downwards. Okay. For example, -2. All right, I have my value here. I have the line crossing at 0, -2. And that's it. There's nothing much to it. So let's look at the other number, the one that we care about right now. That is m. M in this case is the slope. It indicates the inclination of this line. If you see, the value for the slope in here is 1. So that means that whatever point I select on this line, let's imagine over here at -3, -1. That means that if I move 1 unit to the right and 1 unit upward, I should end up exactly on the same line again. So if you see, I end up in there. And I can repeat this process over and over again, okay? And that's what the slope is. So if I start playing with the slope, you will see that the inclination of that line changes. For example, if I set up a slope of 0, right, I have a completely horizontal line. If I play with the intersection value, I see that it is moving up and down. If I continue playing with the slope, now giving it negative values, I have a negative inclination. And that's basically it, okay? What I wanted you to see in here is how this equation describes literally all possible different lines. And this equation will be our objective whenever we're solving problems. How so? Let me show you. Let's go over here. And let's do a problem. Let's imagine that we are given 7x plus 4y equals 12. Okay, this equation is describing a line. What line is it describing? We don't know. But what we do know is that if we somehow can rewrite this equation into this format, then we will know what the slope of that line is. So Let's begin. Let's begin by isolating 7x. All right, we will send it to the other side. So we will have that 4y equals 12 minus 7x. Let's do a little rearrangement. We will have negative 7x plus 12. And then we just have to isolate this 4 in here. We can divide everything by 4, or as some of you say, we can send it to the other side, dividing. So we will end up with y equals negative 7/4 of x. And then 12 divided by 4 will be 3. So if you see now, we have an equation that we can read. Now we know that the slope will be negative 7/4. Now we know that the line will cross or intersect the y-axis on 0,3. But the main objective in here was to know what the slope of that line was. So now we can say that the slope is negative 7/4. And that's it. There you go. Thank you very much. And I'll see you on the next video.